Hello, this is our first video on limits. This is usually the first topic in calculus, always the first topic in calculus. And so limits is mainly just, you're just figuring out how functions behave near points instead of at points. And so you can kind of say that like the opposite of limits would be like some type of value. Okay. In algebra, when we're trying to find how certain variables are changing, we're doing that with respect to those values of that function, right? Where a limit, we focus on how the function behaves around a point. So it may not be actual value of that function, but it has some type of behavior with respect to y or respect to whatever our dependent variable is. And so before we start with limits, we first have to talk about just the notation of limits. So whenever you see a limit, it's usually LIM next to whatever function you're dealing with. And that function can be with respect to x or any other independent variable that you're studying. And so it reads the limit of the function with respect to x as x approaches 3. Okay, now this notation is the second component of limits, where it's telling you when the independent variable is approaching a certain value, what is happening to the y value? What is happening to the function? Okay, and so again, we're not looking at the value of that specific function. What is that value of that specific function as it approaches 3? We're trying to figure out what is the behavior, what is the function doing when it approaches 3? And it's really, really powerful because it's a new aspect of just dealing with functions. So to give you an example, let's say we have electric charge, and I'm going to coin the electric charge with the letter Q. Okay. Now, with any electric charge, there is an electric field, because in order for an electric charge to have electrostatic force, it has to have some type of electric field coming out of it, where the other charges can detect it. So let's say that this is our electric field. Here, let me redo that. Okay. And the electric field, when you're talking about electrostatic forces, you always have to take into consideration of the electric constant. It's always present. All right. And then the way that an electric field works is that it extends out radially. Okay. So let's say, for example, I have an electric line here, an electric line here. And then it's 3D because it's a sphere. And so it has some type of third dimension to it. And you get some type of area that extends out. Now, the thing about an electric field is that as this R, or distance, gets bigger, the electric force gets cut. Okay? And we'll see as I keep extending out my electric lines. And I start to connect them. You see now my distance is twice the greatest. So at this point here, my electric field will be cut in half. And if I do it again, you'll know that essentially the bigger my R gets, the lesser my electric field becomes, the force. And that's just the inverse relationship. And that equation is the electric force equal to a charge divided by the constant times R times 4 pi, because we said that a electric field, it extends out in a sphere. So that's the volume of a sphere. Okay. And if we were to talk about limits as it respects to the electric field, what is happening to the electric field as the R gets bigger? So that would look something like this. The limit of this function, because this is a function is just an equation similar to what we did over here. The limit as R approaches some type of value. All right, now we don't have any values because we're not trying to figure out the actual force with actual numerical values. So we're only going to deal with symbols that represent values. And one symbol that represents a big value would be infinity. And what this is saying is that as R gets further and further and further away, like at a far distance, because infinity is pretty big, the electric field obviously is going to be zero. All right, that's how the electric field is going to be. It's going to turn to the value of zero, because as the function approached the distance, that value, that variable, when that R approached infinity, we find out that the function behaves with no value. There's no force at all. So that's a little concept on how limits work. Thank you.